same notebook that we used previously. That was the water extent notebook. But before I continue, we made mention last week that before you want to work with an already existing notebook, it should be wise to duplicate it. So how do we actually duplicate that notebook? So because you're going to work with the water extent, the first step you do is to click on the water extent notebook, right click it, click on duplicate. So once we click on the duplicate, the water extent notebook, a duplicate of that file will be generated for us. And that file is what we'll be using for this tutorial. The main reason why we duplicate the existing file is normally there are always new updates that is being done on that particular notebook. So for instance, if you are using the water extent notebook and a new update has been done on that particular notebook, what the changes you did to that particular notebook, because you didn't duplicate it, the new file or the new notebook will overwrite the existing notebook. That's why it's always best to create a duplication so that in case the new function is being introduced, it won't overwrite the work you were already previously doing. So that's what you do. So as you can see, the water extent copy has been created here. And also to make it easy for you in the future to identify it, you can also rename it to the area that you are going to work with. Because this one is, with this example, I just name it WX leak import. Because you are going to use an external file, that's what you are going to use here. The next question is, so how do I get my external file onto the Sandbox? Because the Sandbox is a cloud-based services, and the data that you have is actually on your server, on your desktop. How do you actually bring that data from your desktop to the Sandbox? There are various ways to do it. One method is to use this upload files button here. Once you click on the upload files, then you point it to which file you actually want to work with. So once I click on the upload file, the folder actually open it up for us, my folder dialog. So the folder that we are going to go after is the leak. And because you are going to deal with the shape files, you have to make sure that all the shape files are being selected. So once I click on the one, you actually see that the shape file has been uploaded here. This .shs. So you actually get your folder uploaded at this side. But the question is, if you have all our files at one place, it will actually make our folders organized. So to actually have all these external files within a particular place so that your folders will be organized, it will be great to create an additional folder in the place where you are about to work. On the normal Sandbox, if you want to actually import vector files, you can use the supplementary data we have here. So when you go to the supplementary data here, we have a lot of external files, which is actually uploaded onto that section here. So with your work, you can actually right click and create your folder, the supplementary data, and put your files here. Or depending on where you are working, if you are working in the real world examples, because it's only for you alone, you can create a folder here called new folder. So you right click and click on new folder. Then you can name it data or any name you prefer. Just that as soon as you enter into your server or you enter into your instance, you actually know that this is the place where I'm actually keeping all my external folders. So when you go into the data, then you can actually upload all your files here. With this, you want to upload all the shape files that you have here. This one is out and this one is out. So you want to actually upload all the shape files. So once I click on open, all my shape files or all the external data that I want to upload in the Sandbox will be uploaded at this particular point. Is any question on the uploading of the external data onto the notebook? Any question? We'll continue to the next step.
A question?
Yes.
Can I upload the CSV?
Yes, please. You can also upload a CSV and you use that same method. Let me see if I have a, let me look for some of my CSV files around. Let me pick one CSV file here, then we can upload that one. Okay, so let me download this particular file. Okay, perfect. So if you also want to deal with CSV, you click on the upload files. Then as you can see, there's a CSV data here. Then you can click it and you can actually upload it also onto that section. So apart from shape files and JSON, you can also upload CSV also onto the sandbox to do further computation. Iga, please, is it okay?
Yes, it is okay.
Okay. So so now let's continue. So right now that we have all our data available, how can we actually let the notebook interact with the data that we've actually imported? So the ones that we are going to use is the water extent that you just created. And that's the WS Lake import. That's what you are going to use. So I'll open my new notebook, which you've actually seen here. To be able to interact with, by default, most of the notebooks actually comes with the latitude and longitude, whereby you specify the latitude and the longitude, then you also specify the buffer or the long range for it. But if you have your external database, then there are some additional packages that you have to import before you can actually work with the external data. And whilst the notebook are loading, the additional packages that you are going to use is going to be GeoPandas package. Then you're also going to use another tool called XR Rasterize and Map to Shapefile. So these are the 3 additional packages that anytime that you want to import a notebook, you are going to import those 3 additional files. So whilst my notebook is loading, those 3 important files are what you'll be importing from it. Perfect. Okay, so right now my notebook is loaded. The one that you are going to work on, that's the WX Lake _ import. So the first thing is we need 3 packages that you want to import. The first one is you have to import GeoPandas. So within the tools, you have to check whether you've already imported GeoPandas. If GeoPandas is not imported, then you can add them to the packages above here. As you can see, the packages are actually divided into 3 phases. The first one is to import Python packages. So GeoPandas is part of Python packages. So below here, you're going to type import GeoPandas here. And you know the name GeoPandas is long, so sometimes you can abbreviate it. And for a way for Python to know that you've actually abbreviated is to use the ASC command, so as JPD. So what you are trying to tell Python is anywhere is going to JPD, we are referring to GeoPandas. So that's one of the packages that you need if you want to work with an external data. Then the next data that you also will be much more important is the map _ shapefile. The map _ shapefile help you to display your shapefile so that you can know whether the shapefile falls within the area you are interested to work with. And that one is, we get one from the plotting. So the next line, which is the DEF count tools, is the next where you are going to import. And you will get the map _ shapefile from the plotting file that we see. So because we've already imported the DEF tools.plotting, you will just add that method to it, map _ shapefile. So you are going to have that package also as part of the packages that you are going to work with. And the next method that you are going to use is to rasterize. You know, shapefiles comes with this shape, and the satellite images comes as row, pattern row. But we want to keep it to the extent that we want to use. So with that extent, we are going to use the XR underscore rasterize. And that tool is being picked from the spatial section. So we just bring it here and add it to the methods that we've imported here. So as you can see, to be able to work with shapefiles, you need the GeoPandas, you need XR rasterize, and you need the map underscore shapefile. Please, there's also another one that I forgot to add. You also need to, there's another package which works with the geometry. That's also very, very important. And that comes with the data cube. So by default, you also import that section also below the import. How you are going to arrange the import doesn't matter, but to make it more user-friendly, we prefer to load packages from Python packages first. Then you upload, the second one will be upload data cube packages. Then the third one will be upload Digital Earth Africa tools. So any of the, how you want to arrange it, it will depend on your side. So these are the 4 functions that you need if you want to actually import a vector file and work with it within the shapefile. So once we've gotten these 2 ready, we have to execute it. Always, once you are going to start a new thing, the best option is always go for kernel, go to the kernel, then go to restart kernel and clear all output. Or restart the kernel and it will clear all output. And one way of doing that is also to make sure that your memory, a lot of memory is also allocated for you. As you can see from this session, you already see that with some of my tools, there is already a green icon on here. That means although I've closed the notebook, the kernel is still running. So it's still taking some of the memory. So one of the best things to do is just look for this button here, click on it. So although you've closed all these notebooks, their kernels are still running. So when you click on, then you will shut these kernels down. The memory is 320 megabytes is being used. So you shut all those kernels down so that it will actually also allow us to have a lot of memory. So if you have variables that are already stored in the memory, all those ones should be off. And as you can see, once I shut those kernels down, you see that the memory has actually reduced to that set. And if you go to the folder where you are inside, you see that there's no green icon shown there. That means only one particular notebook is actually running at that time. It actually saves a lot of time also from it. Now that we've actually cleared everything, the next step is to load the packages and make sure that all our packages are being loaded. Remember, this side is blank. That means the cell has not been executed yet. Once I use the play button, now it's changed to asterisk, meaning it's running. And once it's changed to a number, that means that it has executed successfully. Once it has executed successfully, any warning that will come here, you can ignore it. Because if it was an error, this warning wouldn't have come here. So for instance, I was supposed to import GeoPandas, then I mistakenly typed import GeoPad as GPD. Then once I run it, let's see what will happen. You will get an error, no modulo named GeoPandas. That means the system will not continue to execute because you've actually gotten an error. So these are some of the things you have to take notice of when executing the modules. Okay, so from here, the next step is to load this function, which will be important, but then we will load our data cube. Because we've changed the app name here, it will be best to also change our app name here to get a unique name for this app. So I just type lake and that's import. Normally, this section can also go with the name of the notebook. That's why I name it WX underscore lake underscore import. You can maintain it with the same previous name, water underscore extend, it doesn't matter. But the best practice is just to change it to the notebook name that you are using it. Then after that, it will be executed. Then you run the dance. Later on, we will talk more about the DAX. Okay, so right now you've reached the area where we are supposed to define our parameters. With this particular notebook, we are not going to work with the latitude and the longitude. How do we define our parameter? The first step, because you're going to deal with a path, because you are dealing with a file on our sandbox, the first step of what you have to do is to let the notebook know where our shapefile is located. And once we know the path, we will store the path as a string to a variable. So for this, we have to define a variable that will store the string name into it. So the variable that we are going to use, I can call it a path. You can call it any name, shapefile underscore path. Then you will introduce quotation marks. The quotation marks is you want to declare a string. That means that particular is not an executable code, but it's just a string. And that's so you introduce it with Python. You can either do the double quote or the single quote. Any of them will be fine. Once it's a double quote or a single quote, it will know that you are defining a string for it. So the next question, how do we define the path? It's very simple. Look at the position where your notebook is actually located. So right now, the notebook is located in the real world example folders. So where is your shapefile also located? Is it located in that same folder? If it's located in that same folder, then which folder contains your data? So within the real world folder, you notice that the WX, Lake import, and the data file are all within the real world folder. So with that, we'll just specify the data. Then we use the /. Then with the /, you just go inside. Then mention the name of the shapefile you want to use. So the shapefile that you want to use is lake.shp. So this is the shapefile that we want to use. Because our shapefile was within the same folder as the real world example, you will just specify the path and we will type the shapefile here. This is when the data, the folder and the notebook are within the same folder. Let's assume that the data that you want to work with is in supplementary data. So to go back, so for the real world example, if you want to go back, you click on the mother folder here, and it will send you back. It will send you back to the mother folder where you are going to have a lot of folders here. But the file that you want to work with is the supplementary data. Once you click on the supplementary data, it will open it for you. And let's assume you just want to work with this particular GitHub banner here. We just want to let the system know the path of it. Remember, the supplementary folder is in a different directory as compared to the real world folder. So what you will do, this is an example, I'm just specifying the path, is because if you want to access the supplementary data, you have to go back, you use the double dot, telling Python that that folder is not within the real world folder, but you have to go back to the mother folder. Then you specify the particular folder, which is going to be the supplementary underscore data. Then you specify it another, then you specify the file that you are actually after. The file that you are actually after is the GitHub banner. So you just type GitHub underscore banner.jpg. So what we've actually done with this part, Python will automatically know that to access the GitHub banner, you have to go back one step. And once you go back one step, you identify the supplementary data. And after he enters into the supplementary data, you'll be able to identify the GitHub banner. So that's how you can actually specify path. So if there is 2 folders back, you have to actually go the double dash folder. That means the Python has to go back 2 steps before it can identify the nearest object, which is actually the folder you want to work with. So assuming the folder is just here, it's not within any folder, how do you specify that? You just bring the double dot, telling Python that it has to go back out of the folder. Then you just specify the file name. So automatically the system will know that, okay, this is the file that I would like to work with. So that's how to actually specify directories when we are working with Python. After specifying the shapefile path, the next thing is we have to read the shapefile into it, because the shapefile is there, it's just a normal file. But how can the system actually work with it now? That's when the pandas actually can see, the GeoPandas. GeoPandas is able to read vector files, it's able to read CSV, it's able to read Excel files. So that's when the GeoPandas will actually come in. So how do we do that? You declare a variable. Remember, you've already declared a variable called shapefile_path. So you declare another variable called GDF. GDF is just a variable. You can call it any name you want to name it. You can call it, let's say, let's use shapefile. You can just name it shapefile here. Let's use it as a shapefile. Then we type GDP. So remember, when we were importing the GeoPandas, we gave it an alias name called GDP. So anywhere you're going to type GDP, Pandas will recognize it. GDP.read underscore file. So these are some of the parameters. Then the read underscore file, we tell him to read this shapefile. That's the path. So I just copy it and paste it here. So what I'm just trying is that the system should read what is actually seen there. Let me copy this. Paste it in this cell. So after having this, you can actually read it. So as you can see, it has been executed. So right now, let's check something. I want us to see something. To know the detailed information, the attribute information in the shapefile. For GeoPandas, you have the simple method that you can actually use, which is the head. So you're going to, it's a method. So shapefile dot, just type the head, and it's going to list the 5 records in the attribute together with the column names for you. So once I have it and I click on the run, that's what you have. So this is the attribute information. And because we are dealing with one shapefile, that's why only one record is shown for us. One record within that particular shapefile. So right now we've been able to access our shapefile using the GeoPandas method. Before you continue, please, any question? Or if you have any question, you can put it in the chat.
Yeah, I have a question, Edward.
Yes, please.
Yeah, I am Bashir. No, I just wanted to shed light on the GeoPanda thing.
Bash, please come again.
No, I said I wanted to shed light on the GeoPanda.
Oh, okay. So, okay, Bash.
Edward, you're on mute.
Sorry. Sorry. So we have the pandas. So pandas is a way of working with vector files or large files. And it actually deals with them 3x3, 4x4, 20x20 matrix. But with the GeoPandas, adding the geographical method to it. So with the GeoPandas, you're able to do external work on arrays, whether it's Excel or vector files or any other data. So what the GeoPandas does is GeoPandas is able to read the shape files for us. That's why we want to use the GeoPandas. And because the data cube is built on top of Python, working with GeoPandas will actually make it quite easier for you to be able to interact with this external data. So what we did was, so for the GeoPandas here is just here to help us to be able to convert the shape files into a format that the system will be able to work with. That's why we are using the GeoPandas here. Please, have I explained?
Yes.
Okay. So what we see here is to use the GeoPandas then the read file. As I said, the GP is an alias name, a nickname for the GeoPandas. We could have typed pandas here, but it could have been long. So just to make it quite short for us, that's why we normally use the nickname. We just shorten it and call it gpd.read file. So anytime you want to read a file, whether CSV or GeoJSON or shapefile, you can actually use this. You can actually use the read file. Let me do a quick example on one of us that we just imported. That's the 2020 phenology. So let me just type 2020 phenology. Yeah. Then let's execute it. Oh, it said phenology, no such file or directory. Remember, the extension is very, very important. The extension, I made it .chp. Actually, it's supposed to be .csv. So also mind me, if it says no file extension, no file or directly is found, you remember that the phenology was typed correctly, but I added an extension of .shp to it. So also those are some of the things you can also take notice of when working with it. Then once I click on the run, as you can see, this is the results in that particular notebook, in that particular notes that we actually executed. To know more method for a particular GeoPandas, after the dot symbol, you can actually go with double tab. So once you click on the double tab, depending on the server, it will read up and give you all the parameters available for this particular region. I know that it also have a read_CSV file available that you can also use. So if I type the read and I use the double tab, you can see that every the pandas have will show up here. So we have the read feature, read file, read PostGIS, read packet. So you can also have that one. But the function that we are interested in and that you'll be using along the way is actually the read file. So now let's go back to our lake.shp. Okay, so right now that you already know these dimensions, the next step is to display our shapefile. And remember, as part of our modules, we use the map_shapefile. So the map_shapefile is what we are going to use here. So you are going to type the map_shapefile. Then you open a bracket. To have an additional information of what a method do, use the shift tab. Use the shift tab, it will give you additional information on how you can actually use a particular function. So the map_shapefile, it gives us that it needs GDF. The GDF is the shapefile that we want, and we also need an attribute column. So these are the two things that are mandatory for this particular function. The continuous, the CMap, and the base map. This one you can leave them blank. System will actually do it for you. So how do you do that? So you specify our shapefile here, because the GDF needs the shapefile. Then it also needs an attribute column. The attribute. And how can you get the attribute column? So looking at the information at the top here, the name, description, the timestamp, begin, those are the attribute columns that it needs. So to make it simple, you can just pick one of it. You can even pick the simplest one, name. Name. Then you execute it here. So once you execute it, it will load the shapefile together with the base map for you, so that you know that the shapefile actually falls in the area that you would want to work with. that you want to work with. So this is the name. The attribute name also should also match the same attribute name here. Let's assume that I change it to small n and I execute it. It gives us an error that so you look at that, the attribute name does not exist in the GeoPandas data frame. So we have to make sure to give it the name that matches in the attribute columns here. So that's also the catch that you also have to refer when you want to run the the map, the Juice server at that particular point. Yes. Okay. Yeah. So in other words, when we type GGP, we can also type GeoPandas. Okay. Let me go back. Because we've actually used the as GPD here. If we type GeoPandas, let's see what will happen. Will the system recognize it? Name GeoPandas is not defined. When we are calling the GeoPandas, we told him that we want to call it as GPD within the cell. So if you run, I want to use the name to call him, the system will never know it. So if you want to use the GeoPandas alone, you don't need to bring the axe here. You just have to do it, import GeoPandas, whereby you'll be able to use the GeoPandas as a standalone. But if you want to shorten it and give it a nickname, GPD is good. You can even call it Geo, depending on how you want to name it, and just give it. Just make sure that anywhere you want to use the GeoPandas, you call that particular name, that the alias that you gave it to you are going to call that alias. Okay, so right now we've been able to got our shape and everything. So with here, we wouldn't be needing the lat long, so we'll just comment them out in the code. The next question, so that now the next task is how do I load the shapefile to be able to pick the area that I want. Right now, you're able to bring all the shapefile into the system, but how do I actually load to be able to pick the area that I want to work with? That's going to be the next step. So how do we do that? Okay, so because I'm not going to be, so let's come here. So at this junction, we are going to get the geometry out of the shapefile. So the GeoPandas has been able to get the form, but to be able to use it to query into a database, we are going to use the geometry. So we are going to use this particular function here. Remember, this geometry was imported from the data cube session, which is this one. So you actually need this geometry function to be able to get the results from the database here. So you just pick out the geometry here. Then you call the function, then you call it the geometry. And remember, we are after the geometry of the shapefile. So you copy the shapefile name here, the GeoPandas shapefile that you copied it here. Then you paste it here for us. And you also paste it here for the system. So right now that you have, then you execute this session. Okay, there's going to be an error. So you have the geometry, then the shapefile and the geometry up. Then you execute, change this one also. Oh, sorry. Okay. So shapefile.cr.png. Unexpected type of jump. I have the geometry here. Let me check this one quickly while we're having this error here. Okay, so you are getting an error here, scalar x. So you have to check why you are getting the geometry error from this particular area. We've already been able to display the area that we are after. Then the next method is to get the geometry, but the geometry is giving us an error. So now let's go and see why are we getting such an error. So let me change this. Then you play this session by shift file. Oh yeah, I saw. This session also by shift file. Then you run it. Perfect. So previously, we didn't specify the feature that we wanted to use. So we used the shapefile.ilog location. Next week, when you go into the details of the data sets, you would explain when to use the iLocation location. So now just know that with here, we specify the first record using the ilog. So the ilog means you want the first record, interested in the first record geometry. So this is the first record that we are picking. Then you pick the geometry out of it. Then you also pick the shapefile CRS. So right now that we've gotten our geom, then the next step is to go into the area whereby you specify what you want to do. So for this particular data set, within the query, we are no longer going to use the X and the Y. So the best practice is instead of deleting it, just comment it out. Then the new parameter that we will use for this particular thing is to use the GeoPolygon. Then within the GeoPolygon, we will specify the geom here. This geom function, just what we just did, we just specify the geom in this session. Then we are good to go. For this particular tutorial, we are going to stick to only 1 year. So let's change the time to only 1 year. Let's pick 1 month. So 2019-01. So we are sticking to only 1 month. Then we get the geometry for that particular region. Then within the layer, because we've already specified the query, the query will be placed here. The main reason why we specify this method or this object is so that we can reuse it again. Remember, with this particular tutorials, we are dealing with DC load and Landsat, WAFs and Landsat, and there are 2 different methods. So using defining a query here, we can actually identify, you can actually put it also here. Next week, we will talk more about how these parameters also work into details with our next week live session. So we can see how best we can maneuver or manipulate things when we reach here using the load ARD and the load DC.load. So right now that you've changed the GeoPolygon to geom, let's execute it. Invalid syntax. Because I forgot to bring the comma, alerted me invalid syntax because the program thought that GeoPolygon is the same as resolution. That's why I say invalid syntax. So then I brought the comma. Then right now let's execute it. Where is the error? Let me take the load RDC off. Then let's run it and see. Okay, so as you can see, because we used 1 month, only 1 image was able to return for us, and that was only one. We had 2 images for the month of 2019 January, but only one of them met the criteria of 75 with quality pixel. That's why we are having that. Right now, you've been able to get our image. We can actually display the image using the RGB method. So RGB, then you talk about the Landsat image we have here. Just talk about Landsat. Let's close it and let's execute it. Oh. So it's going to load that particular Landsat for us. Then we get that region. Okay, so perfect. This is the Landsat that we just load. And as you can see, all the image scenes around this area has come. So using the GeoPandas, you're able to see all the image area. But according to our work, our shapefile, we're only interested in the water body. So how do we chop the rest off and only utilize the water body? That's when you remember we imported the XR_rasterize. That's when the XR_rasterize will come of handy to us. And how are you going to do that? That's going to be the okay, so that's going to be the next step. So how do we rasterize it after getting our image here? Before I go to, that's the last option. Before I jump up to that last option, any question? Any question before I jump on to the last one? Okay, so because there's no other question, then the next thing that you are going to do is to rasterize it. How do you rasterize it? We are going to use the XR rasterize. So we are going to write a simple function here, another variable. Always it's good to have a variable so that you don't actually like keep repeating yourself. Variables actually makes it easier for you to use the data. So you have to create the max. So this is how you create the max. XR_rasterize. Then you call the shapefile. Then you call the satellite imagery, which is the DS_Landsat. What's the satellite imagery? You just go to the DS_Landsat. So this one will create the max first. Then after creating the mask, we are going to use the where command here to take out only the image. So the rasterize will convert the shapefile to a rasterized format so that you'll be able to crop the area you're interested out. So from here, we are going to take it out using the ds.where. So you call the Landsat back, then you put the max here. So that will be done. So now let's execute it. So the max is done. And you would, after that, you just print it out to see the end results of what just happened. Just put it here, then let's run it. So can you see the difference now? You notice that with the first image, it was able to get the area fast, but it brought out all the imagery for the other areas. But because you're only interested in the water body, we're using the shapefile, you're able to mask it out. So this is the procedure we use when you actually want to use an external, either a GeoJSON, KML, or a shapefile to use it to query the system and get the shapefiles out of it. So this is what we have for today's session. Is any other question? Is any question? Okay, so if you go through and you encounter any problem, feel free to reach us, and we are here to support you. Then for as part of next week's session, we'll go into details with if you query out a particular data set, how do you actually manipulate it to get your results out of it? So thank you, everybody. Thank you very much. Over to you, Ken.
Thank you very much, David, for this great presentation. I can see most of them are still shocked. Also, to make it easier for everybody is to see whether there's a topic they would like us to present next week, so that we at least we can make it more interactive. We could have looking at everybody from RCMRD member states, they could be interested in something like in urbanization or what extent or any other topic, especially the animation tool scripts are available on the GitHub. Thank you very much, Biriwe Isa from Uganda. So we're still connected on the WhatsApp group in the RCMRD champions, and also we have other colleagues from other areas. So ours is to see how we can make sure we use this free platform for everybody. I've put our emails there as well, and also we are members of the same group together with RCMRD. And I can see Mushoshoe has a question, please.